In this problem, we're being asked to find the derivative of natural log of cosine to the power of 5 of 3x to the 4. A bit of a mouthful. To do this, we're going to start by recognizing what our outer and inner functions are. So in this case, the outer function is going to be the natural log. The inner function is going to be this big mess here, the cosine to the power of 5 of 3x to the 4. So doing the first chain rule, hopefully we see that there are multiple chain rules that are going to happen here, but the first chain rule gives us the derivative of natural log, derivative of the outside function. We know derivative of natural log is 1 over that thing. So if it's ln of x, it's 1 over x. If it's ln of this blob, it's 1 over that blob. So 1 over cosine to the power of 5 of 3x to the 4 times the derivative of the inside. So let's go ahead and write this as the derivative of cosine 5 3x to the 4. The reason I'm doing this is because if we've solved some of the past problems, we've seen that here the inner function and the outer function are best determined after a rewrite. So here, let's go ahead and do the rewrite. Derivative of cosine 3x to the 4 all to the power of 5. Okay, so the outer function here is not actually the cosine, it's the something to the power of 5, right? It's the exponent of 5. So it's very important that we recognize the cosine is not the outer function. You don't want to start your chain rule process with the cosine. That is not the outer function, right? So at this step, what we see is that outer function is something to the power of 5. The inner function is the cosine of 3x to the 4. Not only that, the cosine 3x to the 4 has its own outer and inner functions as well. So that means we've got two more chain rules to do to get the total derivative. So let's go ahead and do this. I'm going to rewrite our first term from the ln, 1 over cosine to the power of 5 of 3x to the 4. Then I'm going to multiply by our derivative. Let's figure out what this is going to be. So starting with the first chain rule, we take the derivative of the outside, which is something, some blob to the power of 5, which is going to be 5 times that thing to the power of 4, that blob to the 4. Go ahead and plug that in here, cosine 3x to the 4, times the derivative of the inside. Yeah, that was the outside function's derivative. Something to the 5 is 5 times something to the 4. Derivative of the inside is the derivative of this cosine. That goes to our next chain rule, which is going to require us to take the derivative of cosine, which is going to be negative sine of 3x to the 4. And then it's going to multiply that by the derivative of the inside there, which would be 12x cubed. Okay. Now at this step, we'll go ahead and bring everything together. What I see is I have a 5, a negative, and a 12. So that's going to be 12 and 5 with the negative is negative 60. I'm going to have the x cubed. I'm going to have this cosine here, cosine to the power of 4 of 3x4. And I'm going to have this sine here, sine 3x4. All over, there's only one term in the denominator. That's my cosine power of 5, 3x to the 4. At this step, I'm going to cancel out 4 cosines in the numerator and 4 out of the 5 in the denominator. That's going to leave me with negative 60x cubed sine of 3x to the 4 all over 1 cosine 3x to the 4. And here, just recognizing sine over cosine is tangent, I get negative 60x cubed tangent of 3x to the 4 as my final answer for the derivative of this big mess up above.